Hey, guys and gals, welcome to video lesson 4-7, our lesson on inverse trigonometric functions. Let's give it a go. As we know, inverse functions are the undoing functions. They undo what was done. So if the original function is y is equal to sine x being an angle and y being a ratio, the inverse of y, written y to the -1, we call the arcsine x or inverse sine x. Okay? So if y is equal to arcsine x, notice that we've switched the x and the y's. Okay, we've switched the x and the y's. So if we look at the function y equals sine x, I'm going to do that in red. Y equals sine x, it looks something like this. It goes on forever. We can see now in y equals sine x, my inputs are my angles. So on the x-axis we have our angles, and in this case it's 0 to 360 as we know. And my output, my y's, these are the ratios. And as we know, they go from 1 all the way down to -1. Okay? So my angles go from 0 all the way up to 360, and my ratios go from -1 to 1. And that is our regular sign. The inverse sign, we switch that. But now the problem with the inverse sign, and I'm going to show you that we're only going to take a piece. We're only going to take a piece of the sine curve. In other words, I'm only going to take the piece of the sine curve that goes from, okay, this piece of my sine curve. Notice now that my ratios go from -1 to +1. So these are my ratios. They go from -1 all the way up to +1. Okay? And my angles now go from, and let me do this in a different color, now go in gray here from -90, which is the fourth quadrant, all the way up to 90 in the first quadrant. Okay? So notice that the arcsine curve takes a piece of the sine curve, that goes, my angles go from -90 to 90, and my ratios go from -1 to 1. But now the input is the ratio. So the ratios go in, okay, from -1 to 1, and my output is the angle, and it's going from -90 to 90. Okay? If the input, let's got to make a little chart here. If the input, which of course this is in the arc side, if my input, which is my ratio, if it's positive, it goes, the output, the arc sine is going to come from the first quadrant, and that's 0 to 90. If my input, my ratio, is negative, then my output goes to the fourth quadrant, and this is going to go from -90 to 0. In other words, we're going to go to the fourth quadrant the short way. So looking at our curve, if my input is a positive, that's this part of my axis, my y-axis, if my input is a positive ratio, the output goes to right here, 0 to 90 in the first quadrant. If my input is a negative, and we'll do that in orange, if my input is a negative ratio, 0 to -1, my output comes from right here, -90 to 0. So looking right here now, I have an arc sine of 1/2. Notice that my input, my ratio is positive. Therefore, my output, my angle, is going to be a positive first quadrant angle. And we do know that a 30-degree angle has a positive ratio of 1/2. Okay? If I have an arc sine that's a negative ratio, this is a negative ratio. So now I know I'm going to go to the fourth quadrant. Okay? The angle in the fourth quadrant that has a sign of negative 1/2, we know is the 30 in the fourth quadrant, so that's going to be negative 30 degrees, just like that. Okay, here's my cosine curve. It's just a piece of it. We know, of course, that this does go on forever and ever on both sides. Okay, but again, the piece of the cosine curve that I'm going to take, and just to remind you, the input for cosine is typically the angle, and the output, that says angle, the output is my ratio. Of course, that gets switched in the arc cosine, so the input is my ratio, and the output is my angle. Okay? So we're going to just take now a little piece of the cosine curve, and we're going to take the piece of the cosine curve that goes from 0 to 180. Notice now this includes all of my ratios from 0 to 1, my positive ratios right there. It includes my negative ratios right here from 0 to negative 1. This is negative 1, this is positive 1. And it takes my angles now from 0 to 180. In other words, this being 90 right here, if my ratio is positive, if my input is positive, my angle is positive, it comes out in the first quadrant. If my ratio is negative down here, okay, my output is going to be a second quadrant from 90 to 180. Okay, so again, if the ratio is positive, my output is a first quadrant angle, 0 to 90. If my ratio is negative, my output is going to be a second quadrant angle, 90 to 180. Okay? Let's try one. So here we have an arc cosine of 1/2. We recognize that this input is positive. I know I'm going to have a first quadrant angle. What is the angle that has in the first quadrant that has a ratio of a cosine of 1/2? I know that it is 30, 60, 90, so my angle is 60. In the second quadrant now, my ratio, notice that my ratio is negative, so I know I'm going to the second quadrant, which is 0, which is 90 to 180. I'm sorry. Okay, my second quadrant now, this has got to be a 60-degree reference angle, so therefore my angle here, my second quadrant, is 120, so my answer is 120. Notice that cosine is negative in this second quadrant. Okay, these are my tan curves. If this is 0 right here, and this would be 360 down here, here is 180 right here, this is 90, this is 270, this is neg 90 down here, my second asymptote there on the left. The only part of the tangent curve that I'm going to take right now is this one in blue. Okay, I'm going to get rid of all the others. So get rid of those. Get rid of this one. Get rid of this guy. So in my input now, in the regular tan, my x is my angle, my output is my ratio, which means now in the arctan, the input is the ratio, the output is my angle. If my input is a positive ratio, in this part right here, okay, notice that my angle goes from 0 to 90, a first quadrant. So if I have a positive ratio, I go to the first quadrant. If I have a negative ratio, so my tangent is down here in dotted purple, okay, notice now I'm in the fourth quadrant, the negative fourth quadrant. Okay, so I'll write this in purple. My negative ratio takes me to the fourth quadrant, and that one again will go from negative 90 to 0. Okay, so as we look here, this is a little bit different. Let's look at this guy right now. This is arctan of 35. Let's ask ourselves, first of all, what are we looking for? We're looking for a ratio. The arctan this 35 here, that is a ratio. The arctan itself is an angle. So the arctan of 35 is some angle in the first quadrant, whose tangent, so this arctan is this angle right here, whose tangent is 35 to 1. I don't know what that angle is without a calculator, but this angle, the arctan, is this angle right here. Okay? Now, what I want to know is I want to find the tangent of that angle. Well, the tangent of this angle is 35 opposite over adjacent, which is 35. Notice that in this case, the arctan and the tan, sure enough, they canceled each other out, and our answer was 35. But you need to beware that's not always the case. In this case, it looks like the arcsine and the sine might just cancel each other out. I'm looking at sine of 7 pi over 4. 7 pi over 4 is 1 3/4 pi. So I have an angle of 1 3/4 pi, which I know is in the fourth quadrant, because I can make a fourth quadrant angle right now. I'm going to open up half a pi, 1 pi, 1.5 pi, 1 3/4 pi. So I already know my angle is a fourth quadrant angle, and I'm hoping you recognize it would be a 45 in the fourth quadrant, because it's 1/4 pi. Okay, the sine of that angle is negative because it is in the fourth quadrant. It's actually negative √2 over 2, which you should know. Not really that important that we know it, because now we're going to take the arcsine of that ratio. Notice that the ratio is negative, so in sine, a negative ratio takes me to the fourth quadrant. But notice now the fourth quadrant, and I'm not going to say 7 pi over 4. My output of angles goes from negative 90 to 90, so I'm gonna open the angle that way, which is negative 45, which is, of course, in radians is going to be negative pi over 4. So this answer is equal to not 1 3/4 pi or 7/4 pi, but negative pi over 4. Okay, I know we did some of these problems in class. If we may have done all of them in your class. If they're not done right now, give them a go right now. I'll give you a second or two, or if not, stop the tape, and then I will give you the answers. Okay, these answers for number 1 is 45 degrees. Number 2 is negative √3 over 3. Number 3 is √2 over 2. And number 4 is pi over 6. Notice that we have an angle, we have a ratio, we have a ratio, and we have an angle. Okay? Let's try some others. This is from your homework. I'm not doing all of them, but I'll do a few. Let's look at number 11 here. A, I need to find the arctan of negative √3. Notice that arctan of a negative is going to go to the fourth quadrant. So I'm going to go to the fourth quadrant. I know that this tan is negative √3 over positive 1. Well, the triangle that does that is going to be a 60-degree angle in the fourth quadrant. So this is going to be negative 60 in degrees. In radians, it's going to be negative pi over 3. Okay? B, we have an arc cosine of positive √3 over 2. It is a positive ratio. Positive ratios for cosine go to the first quadrant. This is my angle. So I have √3 over 2. So again, this must be a 30, 60, 90 right triangle. This answer in the first quadrant is 30 degrees, or in radians, pi over 6. Looking at number 10, I chose this one second because this one's a little bit tricky. I go to cosine negative 1 of negative 2. Go ahead and throw that into the calculator and see what's up. You got error. How come? Well, what do we know about cosines? The range for cosine, when I input a cosine, the ratio goes from -1 to 1. -2 is too big, so there is no solution to this answer, or to this problem. You cannot find the arc cosine of -2. It just doesn't work. Okay? So looking at B now, I'm going to take the arc sine of a negative ratio. I have -√2/2, so I know it is a fourth quadrant angle. The sine is √2/2, which we know is a 45-degree angle in the fourth quadrant. So my answer in degrees is -45, and in radians it's -pi/4. A couple more here, and then we're DONE. That's done in Spanish. Let's do number, I don't care, let's do 45. 45, 45, 45. I think you probably do this one for homework, but that's okay. In exercise 45 through 48, use an inverse trigonometric function to write theta as a function of x. Looking at this problem right here, I see that theta is right here. I have an opposite and an adjacent. I did that backwards, I know. I have an opposite and an adjacent. Okay, so I know that tan of theta is equal to x over 8. And now to solve this for x, because it said to write to write theta as a function of x, to solve this for theta, I need to arctan both sides. So I'm going to arctan both sides. So I'm going to arctan this side. I'm going to arctan this side. So arctan of the tan, those are going to undo each other. I'm left with theta. Theta is equal to arctan x over 8. And there is our answer. Let's look at number 48, just for the, no, let's do 47, so it's a little bit different. I know now that theta, I'm looking at theta, I have a hypotenuse, I have an opposite, so I know that sine theta is equal to x plus 2 over 5. I am going to arc sine both sides. So when I arc sine both sides, I get arc sine of sine theta is equal to arc sine x plus 2 over 5. The arc sine and the sine, they cancel each other out. Just leave me with theta. Theta is equal to arc sine, and we can write that also like that, inverse sine, in parentheses, x plus 2 over 5. I think I'm done. Nope, we'll do 2 more. We'll do number 71 and 72. So looking at 71, I need to find the tan of the arc sine of -3/4. We're going to start with the arc sine of -3/4. I'm taking the arc sine of a negative ratio. That's going to give me a fourth quadrant triangle. I know its sine is -3/4. So this is -3. This is 4. I want to say it's a 3, 4, 5 right triangle, but looking carefully here, I can see that it's not. I need to use the Pythagorean theorem to figure out my adjacent side. So my adjacent side right here is going to be 16 minus 9. Does everyone see where I'm getting that from, right? Because -3 squared plus x squared is equal to 4 squared. So 9 plus x squared is equal to 16. X squared is equal to 7. So x is equal to positive √7. So now the tangent of my angle right now is going to be -3 over √7, which now when I rationalize is going to be -3 √7, and I'll write it right here, -3 √7 over 7. Looking at the last one here, number 72. I'm taking the cotan of the arctan of 5/8. Arctan of a positive is going to take me to the first quadrant. So again, I'm going to draw my first quadrant triangle. I know the tangent of this angle is 5/8. So here's my angle. Here is my ratio, 5/8. This missing sign is going to be 5 squared plus 8 squared is equal to x squared. 25 plus 64, don't tell me. 25 plus 64 is 89, equals x squared, so my third side is root 89, and that is actually in simplest form. The cotangent of this, and actually I didn't need to find that side looking at this, but the cotangent of this now is going to be 8 over 5. If I had asked for a sine or something, then I would have needed that third side. Alrighty? We'll see ya soon. Have a great weekend, guys. Bye.